guys, and now from this video we are just going to start the second chapter. It's named pressure and its measurement. And before thing we just covered you about the chapter 1, and it's called fluid mechanics. What are the next kinds of fluids and what are the other things of fluids, I just explained in that video deeply. So if you haven't watched it, please go and check and do watch that. So in now today's video, it means in now the next series we are just going to discover about the pressure. So how the pressure acts and what are the benefits of pressure and how we can use the pressure for the entire fluid mechanics and a little bit of other things I am also going to explain in this video to you. So by this pressure we also can learn a lot of other things, why the submarine is still being in the water with high amount of pressure, and what are the DRDO missions has been recently conducted based upon this pressure, and a little bit of lot of other things I am also just going to tell in this chapter. Okay guys, without wasting time, let us get started. So you can see I will just take it and write it down so we can have better and clear understanding. Okay, so pressure is so simple. Pressure equal to force per area. So this is so smallest, it means simplest thing. Suppose you just take, this is my hand is considered as in this area. So in the hand I am just applying little bit of pressure. It means I am just applying open it. So here it means this is the area. This okay, there it is. So this is the area, and here I am just applying the pressure. It means this, if I apply the pressure here, means it will come at the only one location, this particular location. So what I am just doing, I am applying the pressure over the entire area. So the force applied on the entire area. So that's called pressure. So the other thing is, you can see pressure is an average normal force. Okay, average normal force exerted by the fluid per unit area. So we calculate the pressure only with respect to gas or liquid. So the entire fluid mechanics we deal with the gas and liquid. So that's why it's been given here. So the other kind of thing is, you can see it means for the unit for force Newton and for area meter square. So this is both of the unit. So and this is called as Newton per meter square. Is called as Pascal. Pascal. Okay. The next thing is, from this you can just calculate about the MLT, that one. So for Newton, what is here? It means for Newton every time the weight. So weight equal to what will come? It means kg meter per second square. So you just put kg meter per second square, it will be meter square. So meter will get cancelled, and kg next meter second square. So I think so meter, yes, meter will come down, and the second will also come here. Kg meter second square. So m1 upon next L minus 1 t minus 2. Okay, I think so you are getting the amount. So next thing is, mostly in the entire fluid mechanics, kilopascal, kilo means into 10 power 3. Okay, kilo millimeter means into 10 power minus 3 meter. So okay, kilo means kilopascal means 10 power 3 pascal. That's been given. So and next thing is 1 bar. So mostly in the fluid mechanics we usually relate with everything with the 1 bar. So 1 bar is 10 power 5 pascal. So 1 bar is how much? 10 power 5 pascal, and it's about 10 power 5 pascal, 100 kilopascal. Okay. So the next one of the other interesting thing is, as we are being surrounded by the atmospheric pressure. So if a person is there, he is being completely surrounded by the atmospheric pressure. So 1 atmospheric pressure equal to 1.01 to, it means 32 bar. So sometimes you can 1 bar, it means 1 bar equal to how much? 10 power 5 pascal. So you just going to be 1.01325 into 10 power 5 pascal. Okay. Suppose kilo means 101.32 into 10 power 3, it means kilopascal. Okay. So depending on the value also, the everything and unit will be changed. So you can see here guys, the both of the person is so much similar. It means the shoe size is so much similar. You can the force, it means the area of the shoe size is so similar, but the weight, because the both of the weight, it means mass changes. So everything is dependent on mass. See the mass of him and see the mass of him. So who will exert more pressure on the surface? The person B. It means he is 120 kg. So this person will exert more pressure on the surface. So that's why it's being noted earlier. So we can just directly go to a question. Yep, a 70 kg person walks on a shoe and with the total footprint. So what the pressure it means? They are asking the pressure. Pressure equal to force per area. So here force is given, but we do know weight. So weight equal to mass into gravity. So since force has Newton and weight has Newton, so we just combine this. So 70 kg into gravity 9.81 meter per second square divided by area. So area is how much? 500 to 10 power minus 2 the whole square. Okay, I think you are getting it. You just calculate it and you will just directly get the answer. So next thing is one of the most interesting thing. That's this you have to just look it up. So for everything, it means here mostly I'll just draw a line so you will have a clear understanding. So mostly like this. Okay, this is absolute pressure and vacuum pressure. Just draw three lines. Okay, so whenever suppose guys, how to say means okay. Okay, and like that we can just mention. Suppose for example you are it means there is a container here. So now container is completely open. So the P atmosphere, it means the atmospheric pressure goes inside and fully it means P inside also P atmospheric pressure is there 1.01325 bar. Okay, now what I'm just doing, I'm just seal the container, seal this container. I'm just now filling lot of air, it means I'm just increasing the pressure. So this 1 goes to 2, 2 goes to 3, 3 goes to 4. So at the initial what, how much it has? It has 1.0, it means 1.013 bar. So later on it just these to 4 bar. So the what will be the total pressure? You can see the total pressure is 4.4 bar. So it is combination of the P atmospheric pressure plus of P gauge pressure. Okay, I think you are getting the point. So that's the combination. So this P atmosphere plus P gauge pressure is called as P absolute pressure. Okay, so this entire thing is P absolute, and this thing is P ATM, and this thing is P gauge pressure. So most of the times in the question they used to ask this kind of P gauge pressure. What is the gauge pressure? And if they ask what is the absolute pressure, you have to just go and find the absolute pressure. Why you think so? You are getting the point. So mostly at the common reference, this P absolute goes to a 0. After 0 only 1, 2. It means this entire category is 1.01325 bar. And more than the atmospheric pressure, it goes entirely to the gauge pressure. Suppose if we go to the, it means less than 90. It means let's draw 3 lines. Now this is on the PATM. So now the pressure is, it means now we are just pulling there. It means the entire container is sealed. At the beginning it has fully PATM. It means 1.01325 bar. Now what we are just doing is we are just sucking the air outside. Taking the air out, it means we are just completely taking the air outside. It means what it will happen, this 1.313 will go to 1, and this will go to 0.5, 0.2 and 0.1. Like that it will simultaneously decreasing it. So this entire thing will be P atmosphere. Okay, now it will start to decrease. So this is called as P vacuum, and more than that, so there is a limit. So this is called as P absolute. Okay, so it means for example if you want to add in the entire thing, means what you can do, P ATM equal to this, we have to minus this kind of total thing. So for easy understanding, I will just show you something so you can have better and clearly. I think so it's not been given. This is the thing. You can see, you can look over here. So you can see this PV is represented as this, means this P vacuum. P vacuum is represented as P ATM local minus P of absolute. Okay, this PV is represented as this higher minus of smaller. So this will be the higher, this one will be small. So how much the vacuum, it means how much the pressure has been decreased, we can just find out by this. Okay, I think so you're catching my point. So the next thing is we can just go directly. So you can see here guys, the absolute pressure at a given position is called as absolute, means the actual pressure at a given position is called as absolute pressure. It means at the normal, this case scenario I'm just telling. So and the next thing is the atmospheric pressure at the sea level is called as the atmosphere at sea level. Okay, sea level above absolute zero is called as standard atmospheric pressure. There is a two types of thing. One is local atmospheric pressure, and the second one is the standard atmospheric pressure. So we are just reading about the, mostly we do take reference of standard atmospheric pressure. So generally most pressure measuring devices are calibrated to read 0 in the atmosphere. So most of the, it means I think so you would have visited the fluid mechanics laboratory. So in that most of the time the PATM is entirely taken as 0. Okay, and so they indicate the difference between the absolute and the local pressure. So that's, it means we generally used to take the gauge pressure only. So in the entire fluid mechanics, sorry guys, in the entire fluid mechanics we used to take only the gauge pressure. Okay, the P gauge, it means the gauge pressure can be indicated as positive or negative. Pressure below the atmospheric pressure is called as vacuum pressure, and are measured by the vacuum gauge. Okay, there's the other kind of gauge also that is used to measure the vacuum pressure. Okay, this is the relation. So this is so simple guys. just remember this P absolute equal to, it means whenever a thing goes above the atmospheric pressure, this is atmosphere, this is P gauge, so entire thing is P absolute. So P absolute equal to P ATM plus of P gauge pressure. So the next thing is for vacuum. So from the top, okay, P ATM, this is entire P ATM, here 1.0132 bar. From here downwards going, this is P vacuum and this is P absolute. So PV equal to how much? P ATM minus of P absolute. Okay, this is a basic common formula thing. You have to just remember this kind of two things. So the next thing you can see here, guys, it has been given a problem. The reading of a gauge pressure fitted on a vessel is 25 bar. Okay, the reading on a gauge pressure gauge fitted on a vessel is given 25. The atmospheric pressure is 1.03 and the value of the absolute pressure there. So you just add both. Okay, gauge pressure PG has been given as 25 bar and P ATM has been given 1.03 bar. So what is the absolute pressure? 25 plus 1.032. What will come? The answer is coming 26 point something will come. Okay, that's it. Okay, the next question we can just go upon. So you can see in this thing we have to just it means we have to listen in each and everything, because this has been asked in the previous year gate question. So I'll just little bit zoom it. Sorry, zoom so much. Okay, I think so you can see this question. So this is one of the most important question. So question number 1, solution. So here, so what's been given, see this is a gauge pressure that is being taken, because suppose how to say, suppose most of the time you would have known for a, it means for a any puncture shop or any tire shop like that, it will go, it means 1 hour you just refuel, it means this is a bike means this is a comedy bike. When you just go and fill the air in your it means air in your vehicle, especially in the wheel part means what they will do, they will just connect the tube over it, and it means the reading will be shown here. It means for mostly generally for front wheel it is used to be 28 bar, it means 28 it means extra Pascal, or 30 it will be PSI. So this shows the reading, so that's it means based upon the air coming out, the pressure gauge will read each and everything. So the same way, how much pressure the inside has, this is being read upon by the pressure gauge that's been located in the monitor there. So that's the same thing it has been shown here. So you can see here, guys, this the pressure gauge G1 and G2 are installed on the system, shows the pressure PG1 5 bar. It means PG1 for this one it shows 5.5 bar. So the inside pressure it comes upon it, so it shows this kind of bar. And PG, it means PG2, it means this is shown as a 1.00 bar. So the value of P means what is the value of this P, you have to just mention. So I'll just write here so you can have better and clear understanding. So this is G1 and this is G2. So here P. So they literally asked us to find what is P. What is P? So for the what is P? For pressure gauge, for gauge pressure directly given, PG1 equal to how much 5, PG2 equal to how much is given 1.00 bar. So okay, what is the value of P? You can see, guys, P absolute equal to P gauge pressure plus of P atmosphere. So generally you can see P gauge pressure is given, P for G2 it's been given this. Okay, for calculation of P absolute, what will come? P absolute equal to P, it means 1.00, it means Pg2 plus of 1.00132 bar. So P absolute what it comes? 2.01 bar. Okay, it means the combination of the here atmospheric plus this one means the pressure inside here is 1.01 bar, and the atmospheric pressure means P ATM equal to 1.01 bar. So this plus this, it means the pressure inside here is what it will come? 2.01 bar. So the it means it's given the absolute pressure. Okay, you should not forget this is the absolute pressure, combination of the both. Now here, I'll just tell you. So now the entire absolute pressure here is how much? 2.01 bar. So for this one the absolute pressure is written as this, but for G1 this is the it means P ATM. Okay, for this, for the it means outside air is a P ATM, it means comes under 1.01 bar. Okay, now as we add the both this atmospheric pressure and as well as the gauge pressure that is present in it, so it will show as how much? 2.01 bar. So this is the absolute, it means this is the entire atmospheric pressure for the gauge G1. So for the pressure P inside is, this is absolute. So P absolute equal to Pg1 plus of P of ATM of the second bar. So equal to Pg1, this means how much? 5.00 bar plus of 2.01 bar. So how much is going? P absolute equal to, so it's P equal to 7.01 bar. Okay, I think so you got the point. So this is simple logic, but please don't confuse so much. Suppose if you consume, it means if you confuse this means, most of the times the people used to confuse the PATM is 1.011 and how this is related to the inside of the pressure. See, we are just calculating, see, you can see, we are just calculating the entire absolute pressure only, okay? The absolute pressure, this for this absolute pressure goes to this atmospheric pressure, okay? I think so if you not understand me, you just go to a before 1 or 2 minutes video for clear cut information, for clear, when you see what you watch this for a second, you will have a clear cut information and knowledge. Okay, I think so you understood. You can just go to the next one. So before going to the next one, you can just look up on this one. Okay, you can see, suppose in the interview if they ask, okay, Shah Rukh Khan, what is the pressure means, what you will say? Our cute Shah Rukh Khan. Shah Rukh Khan, I am the Shah Rukh Khan. So this is our cute Shah Rukh Khan. Now the Shah Rukh Khan is been asked, okay, what is pressure means? Sir, pressure means force per unit area. Okay, Shah Rukh Khan, see, if you see that there is a road, yes sir, okay, just open and go out. So that's it. So the interview answer should be so much precise. So pressure is external, normal, okay, normal, compressive. Okay, you can see the pressure is acting upon like this. So this is normal to the surface, compressive, it's not tensile like this, it is compressive. Okay, and it's in external. Okay, the pressure is a normal, it means external, normal and compressive force per unit area. Okay, so you can see the external goes to the pressure, the internal goes to the stress. Okay, it is a normal and it's a compressive, so acts downwards. So pressure depends on the mass. So PATM pressure occurs, it means our surrounding, we are being surrounded by the atmospheric pressure. So due to the presence of the air molecules in that, it means air molecules being present in the room and surroundings. So that's why PATM is comes under category. If the pressure less than P atmosphere, it goes to the vacuum. If the pressure is equal to P atmosphere, it is vacuum, it is absolute vacuum. So each and everything is so much equal, means it's called absolute vacuum. Okay, if there is no mass of fluid, then the pressure will be 0 and it is known as absolute 0 of the absolute vacuum. There is no liquid at all. For example, in this, there's a lot of air molecule being present, so any kind of P pressure will be. But in our container, there is no molecules, means P equal to 0. So it comes in the category of absolute 0 of the absolute vacuum. So okay, so this is it means the other kind of thing that you just want to remember. That's it. So the next thing, this one is a good thing, because what is the pressure? Pressure equal to force per unit area. Okay, for this how we can say 1 kg force per centimeter square. So you can see here 1 kg force per centimeter square equal to 9.81 Newton. I'll just tell this kind of thing and other thing, so you can have a 10 power minus 4 meter square. So this is represented in another way. So mostly in the foreign only they used to use this kind of thing, but generally we don't use, so don't confuse so much. And the other one thing is 1 Newton per mm square equal to 10 power 6 Pascal. As the videos goes on, I'll just tell you about this one. So this now it is important, but not that much important. So 1 Newton per mm square equal to 10 power 6 Pascal. Okay, we can just go to the next one. So this thing, okay. See, generally each and every time the pressure always act to the external, normal and compressive. So in the interview, if they ask you, you have to just tell like this: external, normal, compressive. So the other one of the interesting thing is, suppose guys, you can see whenever we just climb over the mountain, it means our Shah Rukh Khan is going like this, and he is going to reach the Mount Everest. While he is going upwards, what will happen? The pressure will tends to become low. So our body has the capacity to withstand 1.0132 bar. So as the pressure goes 1.005, 1.000, so now pressure is being decreased. But our entire, it means our entire organism, our entire muscles and nerves has been built upon this kind of pressure. So as the pressure goes down, now it means this is a thing, this brain has 0.22 bar. Now the surrounding is 1.00 bar, means what will happen? This is a higher quantity, this is a lower quantity. So high energy flows towards the low energy, so this high pressure goes towards the lower pressure. So what will happen? Our rupture of the nerves will occur. Okay, so rupture of the nerves will occur means what will happen? Everything will be in a damaged way. So that's why while you are just going to in the upper portion, our nose starts to beat at the higher altitude. Okay, so this is 120 mm. This represents of PP. At very high altitude, local atmospheric becomes very less. Local atmospheric becomes very less, and compared to the blood pressure causing very large pressure difference. See, 0.011 also it is causing lot of pressure difference when you are just going and traveling to the upper hilly areas. When the pressure difference becomes very large, delicate wall of the veins in the nose are not able to sustain pressure difference, hence it bursts and nose starts to bleed. Okay, so the next other one, the interesting thing, suppose if you just tell this kind of one interesting thing, it will be so much good, because when you go into the top of the mountain, the cooking, suppose if you take noodles, mean the cooking of noodles take us so much longer time. Suppose my home is here, who will be here, our top star Rajinikanth sir, here he is going to have a good noodles. So within 2 minutes he is making the instant noodles, but our Shah Rukh Khan is being at the top of the Mount Everest. So the same noodles packet, the same water, the same heating, everything is there, but for him it takes nearly 10 minutes. So how much is the difference? 8 minutes difference. So what is the most interesting thing is, as I told in my previous video about the submarine, the cavitation. So what happens as the temperature, it means as the pressure, it means it decreases, the temperature also, what will happen? It starts to boil so much quickly. So much quickly. Wait. Yes. See, literally I took my mistake. As the pressure starts to decrease, the temperature also starts to decrease. Okay. If the pressure starts to increase, the temperature also starts to increase. So what is happening, as we are just going upward, the pressure tends to go down. So water, it means here, it means at the Rajini home, water usually boils at 100 degrees Celsius, but here it means in the Shah Rukh Khan's Mount Everest, water boils at nearly 80 degrees Celsius. So at Rajini's house, at 100 degrees Celsius, the water boils and becomes as a vapor. But here at 80 degrees Celsius, the water boils and becomes as a vapor. But for for the entire cooking of noodles, how much we need? 100 degrees Celsius is needed. So for we need to spend extra amount of time, extra amount of fuel need to spend for this noodles or for the Shah Rukh Khan's eating thing. Okay, I think so you're getting the point. So this is why you can see here at most of the time it means 0.8 bar will be 80 degrees Celsius. So noodles boils at 100 degrees Celsius, so more heat should be supplied. So that's why we are using pressure cooker. So while we are using the pressure cooker, the pressure, it means the inside pressure always remains same. So instead of just boiling in an open area like this, if you use pressure cooker, that is one of the goodest thing that can pay us. Okay, I think so, getting the point. Next thing, this one, I think so, okay. PG, okay, this one, okay. Okay, this one, okay. So this one, guys, literally this is one of the good thing, but I don't want you to just confuse across you. So for the Pascal, you just need to remember only the equation. It means only the statement is so much enough. So if you know the statement completely, means it will be asking a lot of questions. So you can see this Pascal law was entirely discovered by one of the greatest man, Blaise Pascal. In 16th century, he just found the entire thing. So what he has just is pressure applied on to the confined fluid increases the pressure towards the same amount. Suppose if you want to see, guys, suppose I have to say derivation, this is only that. This also not okay. For example, guys, if okay, how to say, suppose if I told in this way, means it will be a good thing, but it will literally confuse you a lot. So okay, what they have just told is, they have just taken, it means like this square, you just cube they have just taken and they have just cut it. So this is the cutting, so you can see here cutting. So after they have just cut it like this. So okay, like time here the pressure P1 will be here P2, it means X direction, this is Y direction, and this is in another direction. So like this, so each and every component like this will be like this. Okay, so it means each and everything is being taken different compound. It's like a wedge shape. So it is generally comes as a wedge shape, which means we are just cutting the cuboid in a diagonal way. So it means this kind of everything is must not be needed. Okay, so simply one thing you just assume, guys, for the Pascal law, for the pressure, so one thing, the fluid should be static. Okay, static fluid. Okay, and acceleration should be 0. Okay, first I will just write down and later on I will just tell to each and everything. And the fluid element strings to a point. Okay, so the entire Pascal law tells about this. Suppose guys, if a fluid is, it means I'll just give you an example where my water bottle is not there. Okay, one second, I'll just knowing about that in the phone event set, I'll just water bottle. This is coming in a kit way like that. See, you can see here. See, in this inside the water is there. See, in this inside the water is there. So the water until now it's not moving. Okay, the fluid should be in a static. Okay, this is a static, not dynamic. Dynamic means it's moving. And here any kind of acceleration is been acting. No, acceleration is zero. Okay. The next thing. What is the next thing? The fluid element should sink to a point. So the entire thing we are not considering about the entire pressure of the water bottle. We are just taking only one point. So in this only one point, we are just noting down each and everything. This, see like this. It means the entire the bigger shape is entirely changed into smaller dot-like structure. Okay. Here the each and everything is acting. So you can see here guys. Here P1 is acting, P2 is acting, and P3 acting. So we are just shrinking this entire thing into small point here. So as the small point is been acting, this P1, P2, P3 is been acting. Here what should be? The fluid should be static. The fluid should not move. Okay. This is the important thing guys, because for the after the 5 to 6 chapter the pressure will be continuously changing, because here we are just talking about the only static fluid, but later on we are just going to talk about the dynamic. The pressure also changes while the fluid moves. Fluid means the liquid as well as the gas. Okay, here the fluid should be static and the acceleration should be zero, and every bigger shape, this it means this dx dy everything comes and shrinks to a smaller point. Okay, dx dy then this is equal to 0. Okay, see, pressure at a point in a static fluid is equal in all directions. Since pressure at a point is same in all direction, it has a magnitude but not specific direction. Okay guys, it doesn't have any kind of specific direction. So the pressure is a scalar quantity. So you can see here it doesn't have a specific direction. Okay, suppose if means if a police, it is a police, it means Shah Rukh Khan is a police and Rajinikanth is a thief. So when it means for a thief is running in this way, means how the police should run. Should he go in this way or should he chase him in this way? Okay, you can see the velocity goes on the which quantity, the vector quantity. So it depends on the direction also. So pressure doesn't depend on direction. Whenever a thing is depend on direction, it comes to goes to the vector. Whenever a thing is doesn't depend on direction, this pressure doesn't depend on direction, it goes to scalar. Okay, see, my handwriting is not that much okay in it, but I think so you can understand what I'm just trying to convey to you. So the next thing is Pascal law valid for any fluid. Okay, the real fluid, ideal fluid. Ideal fluid, I just told you about the imaginary fluid. Real fluid, ideal fluid, any kind of fluid, compressible, incompressible, Newtonium and non-Newtonium. As I just told you in the previous chapter, the Newtonium fluid and the non-Newtonium fluid. So fluid in a container which is moving with a constant velocity, constant acceleration and a uniform angular velocity. Okay, wow, see, this is one of the good things. See guys, one thing, as I told about you, the pressure should be static. It means it should not have any kind of acceleration. So if it doesn't have any kind of acceleration, means we can just conclude about the Pascal law. Suppose you can see here the pressure. So what will be the pressure? So for example, this point has a pressure equal to 1. So the same way for this point also pressure equal to 1. For this point also the pressure equal to 1. So constant velocity and constant acceleration and constant, it means uniform angular velocity. You can see guys, suppose if this it means you just consider this container is moving. This is a advanced BMW truck. So this container is moving, and what is happening, it means the water is inside important. So here the pressure is 10. It means this molecule has pressure 10, this molecule has pressure 10, this molecule has pressure 10, this molecule also has pressure 10. Now here is the Pascal law valid? Yes, definitely valid, because each and every value of the pressure is same. So since the pressure is independent of the direction, no direction is dependent upon. So the pressure value is equal in all directions. So what will happen? So the pressure is, since the pressure is equal in all directions, it doesn't matter everything. Now the Pascal law is valid. Okay. So the next thing is you can see guys, lot of time you can see about the lifting of the car. So only little bit of force is applied here. Here we can get a lot of thing. So here the pressure force will be same, and here also the pressure force will be same. So suppose guys, if you haven't just tried this one, you just won't try this one. So here they will apply a little amount of force, but here the amount of force will be so much, so we can have a easy of lifting. So this is why the most of the thing we are just using the hydraulic jack. Here it means here the force is applied, here the force 2. So it means pressure equal to force by unit area. So F1 equal to F2. So P1 A1 equal to P2 of A2. Okay, here the 10 Newton is applied, means suppose here also the 10 Newton, but it will be going in a multiplied way. So suppose here 1 bar, it means here 5 bar, let us consider 5 bar into the area is so much lesser here, so 1 meter cube. So but here the area is literally so much higher, so P2 equal to into here the area is literally so much higher, means let us mention 10 meter cube. So you just multiply here this meter square, and P2 will be just multiply with 7. So what will come? This will come 0.5. So here the pressure will be literally so much lesser, so it can have a tendency to lift, means go easily upwards. But when you just multiply this kind of two things, the pressure and it means this how much will 5, this also will come 5. So okay, so guys, suppose if you have just seen this kind of things in your real life, means definitely I think so you can understand this. Oh my god. So this is a kind of hydraulic jack that is used to lift vehicles. See, like this. So we are just giving, see guys, see, wow. See, in this we are just giving how much? Small amount of force, but here the lifting has been increased tremendously. Here the small amount of force is here the small amount of force is given, here the lifting happens so much quickly, so much higher. Okay, I think so you are getting the point. So we can just go to the next one. So derivation, this is how it is. Pressure is a compressive force per unit area. Pressure at a point in a fluid is same in all directions. Yes, that's correct. It has a equal, it means it has a magnitude but not specific direction, as correct. It is scalar quantity, as correct. It is valid for liquid, means fluids in motion, as well as it means in motion as well as in rest. So as I just told about rest means static. So in motion means velocity should be constant, the acceleration should be constant, and the uniform means angular velocity should be, angular velocity means I'll just tell about that in the next upcoming videos. Okay, and next thing you can see, this is the question. Pascal law states that pressure at a point is equal to all direction in, when will be the fluid at rest? Yes, fluid or liquid at rest? Fluid at rest. Okay, fluid comes in the category of both liquid as well as gas. So you should not confuse guys. Suppose if it is being given a liquid at rest and gas at rest and fluid at rest, means you have to just take fluid at rest, because fluid consists of both, like means air and gas. Sorry, air and liquid. Okay, I think so you are getting the point. Okay, just we can go to the next one. So next one is one of the topmost interesting thing. Suppose if you haven't just read this one, please do go and read. I think so this definition must not be needed for this entire definition. Suppose this definition will definitely confuse you. So I think so for this no need of definition. So you just, this is the water surface. Here the submarine is located. So here the submarine is located. So while you are just going deep into the water, the pressure tends to increase. So how much the pressure will increase, we literally don't know. So that's why they do have a formula called pressure equal to rho GH. Okay, rho GH. So here the fishes also will be, it means here the fishes, and here a mermaid is sitting, it means mermaid who is so much deeper to love Shah Rukh Khan and to love Rajinikanth, and also very much interested to marry them. So here the mermaid is there. So when you take this kind of this entire thing, here submarine, here fish is there, and here mermaid is there. Let us name this mermaid. Who we can name? She should be a top actress. Okay, who one? We can just name it as Emma Watson. No, Emma Watson is a good thing, but okay, let us name the mermaid name is Emma Watson. So the pressure equal to the density is this water density. Water density is 1000 kg per meter cube. So what is the unit of gravity? 9.81 meter per second square. So what is that? So distance 10 meter. So into 10 meter. So you just make a multiply, so how much it will come, that's the pressure in it. Okay, I think so you're getting my point. So everybody in this location, in this location will have the same pressure. So this is called as hydrostatic law. Okay, see this is the reference point. Okay, as we are just going downwards, so one thing, dp divided by dz equal to rho g. Okay, it means as we are just going downwards, this will come, but if you are going upwards means what will come, dp by dz equal to minus of rho g. This z is represented as height. Okay, see this is the main formula, that your dp by dz equal to rho g. If we are just going downwards, from here downwards, dp by dz plus will come. Suppose if you are just going upwards means what will happen, upwards the pressure will start to decrease, but downside the pressure will start to increase. So positive, here negative, so minus. This dz is represented as a height difference. Suppose if they ask the question like a little bit of integrated way of how, like this means p1 p2 and here h1, here h2, that means dp p1 of p2 of p2 of p1 equal to rho g h2 of h1 dz. So like this the formula will come. So this is a little bit of integration. So I think so you're catching a point. So guys, little bit, this is a simple formula, but you should not forget it, you should remember it. Okay, so you can just go to the next one. I think so this is enough, because in tomorrow no, we can just cover a little bit, and we can just within the next 1 hour I think so we can cover this entire chapter. Suppose if we cover for the next video in 1 hour means definitely this chapter will easily be concluded, and we can just directly go to the problem, since it has a little bit quite longer thing, because guys fast we are just learning fluid mechanics in a deeper way, we will have a better understanding how the fluid works around us. Okay, we can just go to the next one. So the next one is, this is also one of the interesting things, but I think so you need to remove just the formula. So we are just for static fluid, compressible fluid, isothermal. Isothermal means temperature is 0, it means temperature is constant, not 0, temperature is constant. Okay, for this what will be the pressure? See like this, here P1, here P2. So who is at P2 top? Shah Rukh Khan. Here P1, here who is there? Rajnikant. Shah Rukh Khan, Rajnikant. So what will be the difference as it is in isothermal? P1, P2 equal to P1 e power minus GRTH. Okay, you would have recognized about GRT. GRT means it's a jeweler. GRT. See, this is a jewel shop, GRT. So you have to just remember GRTH. So while you just went for GRT, you just sneezed H, like that you have just sneezed there. So that's the thing. So the pressure P2 minus P1 equal to E power GRT into H. So this is isothermal. So the same case scenario, static, compressible and non-isothermal. So what will be the formula? So in this formula it will be a little bit different. P2 by P1 equal to T naught minus alpha Z2 by T naught minus alpha Z1. G by, it means R of alpha. So this alpha is a lapse rate. Mostly this question is not asked, but literally you have to just remember, that's it. So if you remember, it means it will be a good thing for you. So it means P2 by P1 T naught minus alpha of Z2 divided by T naught minus alpha of Z1 G by R alpha. Okay, I think you are getting the point and catching the point. Okay, now you can just go to the next one. So this is not that much important, but you have to just remember. So the basic formula is T equal to T naught minus of alpha of Z. T equal to T naught minus of alpha of Z. Okay, so now you can just go to the next one. So this is a thing that I just told about you. So it means del P, as I just told, P equal to rho G H. It means del P equal to rho G H, same thing. So not a biggest changing or varying thing. So it used to vary. So you can see here, guys, here it means here 1 point, it means pressure is P18 pressure, so equal to 1.01 bar. As we just go down, the pressure starting this, here 1 will be, here 5 to 6 will be. So the pressure also varies linearly. So you can see here, guys, here del P equal to rho G of H. So 1 1 1. So suppose P equal to rho g h square means here it means as it means square it varies parabolically, or suppose P equal to E rho g e power h means now we can say pressure is varying in the exponentially. So depending on the formula itself we can just tell it varies linearly or in a parabolically or a hyperbolic or any kind of exponential thing also we can just tell. So the next thing is sometimes you would have seen about the divers. It means the person who goes deep into the sea. Deep sea divers. Deep sea divers. So okay, this is our deep sea diver. Oh wow, see he is beautiful. Okay, the deep sea divers. So you can see when a person has deep sea divers, you can see there is a cylinder around him. So why is the cylinder around him? You just think what will be the main reason that he is carrying this extra cylinder. Many of the people will say he is carrying the oxygen cylinder. Okay, because while we are just going deep in the water, they don't get any kind of oxygen. So he is just carrying the oxygen. But you should not think like this, guys, because as we are just going deep into the water, so now who is there? Shah Rukh Khan is there. So if the Shah Rukh Khan is entered without the oxygen cylinder means his body has only how much pressure? 1.0132 bar. Now the entire thing, it means surrounding thing is comes under 0.2 bar. 2 bar means what will come? High to low. So each and everything will crush him. So while crushing him, he can't do any kind of thing. Without oxygen, he will just die. So what he will do? He will carry the oxygen. That will supply the blood, means that will supply the extra amount of pressure in our blood vessel. So it can, our body can able to manage it. So if the surrounding is 2 bar, and if our body is also 2 bar means what will come? 2 equal to 2, we won't die. It means we won't be crushed by the water. I think so you are getting the point. So you just think logically. So that's why most of the people used to carry this kind of oxygen cylinder to maintain the stable body pressure around us. And because our lung do have a capacity to expand so much. So that's the main thing that they are carrying this kind of cylinders around us. Okay. The other kind of point also they are carrying because they need oxygen, because while we are just going deep in the water we don't usually get any type of oxygen. So you can just see, you can see this is a simple thing and this is also a simple thing. And guys, you can see whenever it means you also change the liquid also, like this is inclined or any kind of way. We are just taking only the height. You should not take this kind of, it means inclined height you should not take. Only it varies, it means for the pressure only they varies linearly. So it means if you just this is a straight thing and you are just taking the pressure. Suppose if you just incline also, you have to take this kind of height. Okay, this side only you have to take. So you can see this height is P2 minus P rho g of x. Okay, you should not take any kind of other height. So see, this height must be taken. So this is also another thing. This must be, you just need to look upon it. Okay, I'll just, while going to the problem, I'll just explain this. Pressure diagram 2D diagram and pressure prism 3D diagram. Okay, this is on it. Oh yes, I think so. We can just conclude this video, but after this we can just see in the next scenario. And I hope so you just like the video. If you like, you just put a like and share and just comment what is the thing that I want to just do. Okay, so let me see you in the next video and have a good day. Tata, bye bye.